this segue to this next feature called multi-version concurrency control. So who's familiar with multi-version concurrency control? Okay, a few people. This is an exciting topic. This is how InnoDB is slower at reads or not slower than MyISAM. It's really quite good when you've got a lot of people in a system at once. It gives very good concurrency. Let's talk about how it works. So here we've got a social networking website. We've got three tables. We've got users. Users write blog posts, and users can be friends with each other. In this case, Morgan is friends with Tom. Tom is friends with Morgan. Baron and Morgan are friends, and that is a mutual relationship there as well. So on this social networking schema, I'm going to do an operation. Doesn't matter what operation I'm going to do, but I'm going to do a backup because it's the easiest way to explain why this feature is required. So I'm going to back up these three tables. I'm going to start with the users table, and I'm going to read through it. And I'm going to start reading through the blog post table, and I'm going to back that up. And while I'm backing this blog post table up, and it's taking me quite a while, let me just zoom back on that for a second. This is a multi-user system, so someone else is doing something. And that someone else just inserted a new record that wasn't here before. They inserted this user, Justin, who likes pizza. And this new user, as soon as they were inserted there, they decided that they were going to be friends with Baron. My operation at this point is still backing up through the blog post table. It just finishes, and now it starts backing up the user friendship table. And we have a race condition here. Here's the data that I would have if I tried to restore from backup. Can you see the dilemma? I had already backed up the users table, and then I started backing up the user friendship table. And now I have this data, and I didn't want to see that data. One of the rules of databases, one of the rules of consistent reads, is that we have to represent a single point in time for any database operation. That single point in time can be the start of when the operation runs, or it can actually be the end of the operation. It doesn't matter. We have to represent a single point in time to be able to stop these race conditions from happening. This is an ACID requirement for consistent reads. And we can drop some of the consistency requirements a little bit. But anyway, let's explain, for example, how MyISAM solves this problem so we don't have any race condition. So we want to back up these three tables. Here's what MyISAM does. Read lock. Now nobody can write to those tables. Other people are allowed to read to them, but nobody can write to those tables. And now let's back them up, and we get a consistent view of the data. This really hurts performance. Readers block writers. How does InnoDB do this? Well, InnoDB has this hidden metadata, the transaction ID, and missing from my slide, there's also another column called rollback pointer, where basically as you're reading through this data, you just remember a series of coordinates. I'm transaction number 100. I can't see past 100. If there's a version called 101, don't let me see it. If there's a version older than this number, don't let me see it. I'm just going to be able to see these changes. And by remembering this set of coordinates, there'll be multiple versions of a row. You'll only see the ones that you were supposed to be able to see. And you don't have readers blocking writers. You get very good concurrency. And I just have a little snapshot of showing those coordinates working in ShowNoDB status. And it reads the old versions of rows from undo space. Okay. So now we're up to some of the more advanced features.